So yesterday we discussed about how to give simple queries, and we also saw how the join queries looks like. But everything was based on the queries. We read the data using the data source API. We get a data frame. To that data frame, we should give a table name. Only then we can give the queries. So the way the table name is given is through an API called register as temp table. So that is in data register as register temp table. But in the latest version, you say create view. Latest version, you will say create view instead of temp table. It is just you can say that you are giving a name to your data frame. After that, we give all kinds of queries. Now what we will do is we will see how to give the same things through the data frame API. We will see this part now. It's almost same. There is not much difference. As I said, it's the individual choice whether they should go with the SQL query or the data frame API. Again, search for Control Shift N, search for simple queries. We had two files for simple queries. One we have already sent, which was based on SQL. One more is data frame data manipulation language. As usual, we are creating Spark context, SQL context, and setting the partition as 1. As usual, we are reading our data. This time we are taking both as CSV file, but we know that we can read any data source. We can read any data source. So data, we are using the CSV. We got our sales.data frame. Now we need not register it as a temp table. So that's the difference here. You need not register it as a temp table. Temp table is only required if you want to give SQL queries. Here it is not required. We just give start calling the method. Here we have the select method itself. Select item ID and we can say distinct. So we get all the distinct item IDs. Now we have aggregation. I want to compute total count of the records available. So on sales DF we call the aggregate. Here what kind of aggregation we want to do? We want to do the count aggregation. So it will give a total count of your records. Similarly group by again on the sales data frame we say group by customer ID, but whenever we group we have to aggregate certain things, otherwise we'll get a error. We know that it's a common thing we in RDBMS. Whenever we do a group by something we have to aggregate. So since we want to compute the total amount per customer, I will aggregate amount paid column. I will aggregate the amount paid column, and what type of aggregation I will do? I will do sum. I'll compute the total sum. So as you can see here, it's almost looks like a relational style programming itself. You are no more writing any any functional style programming. So you kind of lose the functional style programming with the data frames. With data frames, it's always either you go with the SQL query, or data frame API. It's almost always relational style programming. Similarly, if I want to do item wise count, we had already seen the SQL query. Similarly here with the data frame API it is the sales or data frame group by item ID aggregate item ID aggregate count. So what type of aggregation we want to do? Count. What type of aggregation we want to do? Sum here. So it's the almost same. So let's run this program, and once we do that, any and this is a kind of an operation. Whenever we do an operation on a data frame, it always returns a new data frame. So this is a new data frame. This is one more data frame. Similarly, this is a new data frame. Just like RDD, any operations you do in RDD, we get a new RDD. Here also any operations or any queries we do on a data frame, we always get a new data frame. So on that, we are just calling the show method, which is the action. So let's run this program and check for the results. We should get the same result that we saw yesterday. So it is giving some error. Let me check the error. Cannot resolve column amount paid. Okay, we changed the column name as item value, and I'm still using amount paid, I think. So the column name is item value. So column name, when we do aggregation, what column on which you want to do the aggregation and what type of aggregation we want to do. So we should get the same result: distinct item ID, total count 14, item wise count, and total amount per customer. Total amount per customer. So it's almost same as you're writing your SQL query. Now let me also show you. So if you remember, we talked about sessionization when understanding Spark core. We talked about sessionization example in which we saw how the uh, sorry, how hash partition works, how custom partition works, how map partition higher order function is being used. We saw all those stuffs. All those stuffs. So we will also see how the same thing is done with the data frame. So you can open the e-commerce marketing pipeline, because that example is there. The sessionization example is in e-commerce marketing. So if you remember, we saw this repartition. This is our custom partitioner. This how we repartition and sort within the partition, and how we transform the RDD into key value. Sorry, key value pair. So the same thing, mine sessions from source. So you will also see that there will be mine sessions from source underscore data frame. So here you need not convert it back to a data frame. Sorry, you need not convert into an RDD, then do all kinds of operations. We have our data frame. We have our data frame. We just say source dot repartition. Use the number of partitions, and we are saying partition by user ID. Partition by user ID. That's what we did, right? We did a partition by user ID. Then we will say sort within the partition by user ID, IP address, and timestamp, and rest all remains the same. Rest all remains the same. And here last time we saw that we take each RDD. Sorry, we take here again it receives a data frame. You take that data frame, and dot RDD we know that always returns a RDD, and we know that that RDD will be RDD of row. So if you remember that, so I will just make it as just to showcase. So if we see here, so when we get the RDD from a data frame, the RDD will be always RDD of row, RDD of row. Now from the row, so we never saw this. I just said that this method will convert a row into a key value. We always have to convert into a key value so that hash partitioner picks up what is the key. So dot key by will transform into a key value pair. But our data is in the form of row objects. Our RDD is in the form of row objects. So this function, if you see the definition of this function, if you see, it takes each row, it takes a row, and the way you get fields from a row is in this fashion. This is all about your RDD. I mean, I will just showcase a simple thing. I think this will be a complex when we put it together. What I'm trying to say here is from an RDD of a data frame, if you want to access fields, how we can access it. I will just showcase a simple queries. So you have your data frame here. So this is your data frame, sales DF. Now if I want to get the RDD back from this sales DF, we know that we have to just say sales DF to a dot RDD. So sales DF dot RDD will return and RDD. But if you see this RDD will be in the form of row objects. It is not in the form of any custom any class that we have defined. Now how do I access the fields of row objects? How do I access? If I want to use functional style programming, let's say I want to select only item ID and customer ID. Now this is an RDD of row, so you can use just say map. You can use the map higher order function. We know that each object is a row object. R is a row object here. R is a row object. So if you want to get any field from this, you have to say R dot get. So as you can see here, there is get as method it has. Then you specify the field name, you will get the value for that field name. So you can use get as, and you can say field name is item ID. I will return a tuple here. Dot get item value. So this is how you access the fields of a RD that is extracted from a data frame. I mean, it's not so user friendly. I mean to say, you can do functional programming. The idea here I want to say is functional style programming is possible still, but it is not so user friendly, because internally each object is a row object, so you have to adhere to the APIs of the row objects. It is not like RDD of sales. It is not like something like this. It is when we have RDD of sales. So if you see, so this is sales RDD. So as you can see here, RDD of sales, you can do map transformation. You take each record. We know that each record is a sales object. You can say dot item ID comma r dot item value or amount paid something. Amount paid. So if you see, this is much more when the data is in the form of some class object. So functional programming looks much easier and much more compact if you want to select only item ID and the amount paid. But when your data is in the form of a row objects, so you need to use the APIs of the row objects to extract whatever columns you want to extract. Either you use the field name or you can use the index. So you can also use the index, but field name is more readable. So from a data frame, if you get an RDD, on that you can, from that RDD you want to extract fields, you will use these kinds of APIs. I'll just delete it, and the same thing is being done. Same thing is being done there also. Row object. So you get the user ID, then you get the IP address, and you get the timestamp, and you create a hit key class object. Hit key class object. Yes, Samir, it is being recorded. So this method, this function we are passing to the, this function we are passing it to the key by. Again, key by is a higher order function. We know that key by is a higher order function. It takes a function, and whatever that function returns, that will be made as the key. Now we know that this function this function returns a class object, hit key class object. So obviously that will be made as the key, and the whole row object will be the value. Whole row object will be the value. You can see here how it looks like. So key value already is nothing but we have the hit key as our key, first element of the tuple, and whole row object is our value. So based on that, our repartition will happen. Custom partitioner will be coming into picture, so that we can bring all the records with the same user ID to one system. Always it has to be in the form of key value pair. And if you see here also internally all these things happen. Whenever we say group by customer ID, aggregate by things, internally everything will be in the form of a key value pair. The shuffling will happen, hash partitioner will come into picture, but all those things are abstracted. All those things are abstracted because we are using the normal SQL queries. So actually I'm going to and fro from this e-commerce pipeline because we had left out some point. So that's what I am discussing, because those points will only make sense when we have learned data frames. So I hope this part was clear. This was already of row objects that we want to transform into a key value pair. We want to see what is the key. So obviously we will use this from function. And at the last, if you see here, we are adding our session ID as a new column. This also we had not discussed. We had just seen the sessionization. So here we are adding session ID as the new column, because we saw how the programmatic schema works. Programmatic schema works. So this was our original schema. From the data frame, schema.fields will give you the original schema. So I will go back and showcase in a simple form. So this is your data frame. So this is your data frame. Sales df dot, if you see, schema dot fields. It will give you all the array of struct field. You can, if you want to change your column name, anything you want to do with the column names, you can make use of this. So it will give a struct field. We know what is a struct field. Struct field contains the column name, column type, and whether the column value could be null or not, nullable. So this is your existing schema. So if you want to add a new column to this, because this is an array, this is an array here, this is an array. So if you want to add a new column to the existing columns, you just need to add one more struct field, one more struct field to this array. So that there are methods like colon plus. Colon plus is a method actually on a array, and we can add some struct field to this. Struct field, we can add one more column called as just say date. It will be string type, we'll say, and we can say string type, import the string type from the Spark SQL. So we are adding this field, a new column to your existing column. So your schema will be now also having the date column. So that's how you add a new column to your existing column. Suppose you want to do something. I mean, there are other ways also to do this, but at the column level, if you want to do that, so we are adding. So if you see here, the same thing is being achieved here also. So from here we created session ID. From this, we created the session ID, and we want to add session ID as a new column. We want to add a session ID as a new column. So we take the existing column, source dot schema dot fields is our existing column, because source is the data frame. Source is our input data frame. We take the existing column, add, append. This plus colon plus is nothing but a method on an array. It is a method on an array, so that you can append anything to the array. If I showcase on the Scala here. So if I say nums dot, I think it will not show here, because you have to just say column plus int. So it will append an element to the tail of the collection. Colon plus is a method on that, and the same method we are using here. Same method we are using here to the existing elements of the array. It will append the struct field to the end of the array here. So we got a new field. So that's we created a new data frame with this new RDD. We after doing sessionization, we get a new field called RDD. So that RDD we want to convert back into a data frame with the new column, and this is our new. So few things that I had left, I am explaining there. As you can see, it's being done in the same fashion. So I hope the things were clear. I hope the things were clear. I think a bit it was out of the go. I mean, it was not planned actually. I just tried to showcase that as well. The I mean, the what I wanted to showcase here is data frame APIs or SQL APIs, SQL queries, both are relational style programming. You lose functional style programming. You can use the functional programming, like you can use map hierarchy function, filter, all these things you can use, but your RDD will be in the form of RDD of row objects. Each element is a row object. So it will not be RDD of like sales or RDD of customers. It will not be like this. It will be RD of sales. So you don't usually, it doesn't look so elegant to apply some transformations using the row of, but still you can still do. Otherwise we say we lose functional style programming. Because of this we are losing a functional style programming. And we also saw how the sessionization works with functional style programming. This repartition API that I have showed, this is data on data frame repartition method. You repartition your data frame based on the user ID. All the records with the same user ID will come to one system. This method is available from 1.6 only. I think it is not available in 1.5. Up till 1.5, on data frame you don't have a repartition method on data frame. So it is only available from 1.6 onwards. Slightly different, as you can see here, this difference. This is data frame based repartition and sorting within the partition. This is RDD based repartitioning and sorting within a partition. That is the secondary sorting. So that's the difference between data frame and RDD APIs. Otherwise, map partition is same. Map partition is same. Only thing is, everything will be in the form of a row object. So you always need to get in the form of a row object. So if you see here, this iterator, now this iterator will be iterator of row object when we use a map partition. Every record is a row object. Now if you see the iterator here, now right, we here also we convert it into RDD. It will be a row object. So that I wanted to showcase how we can apply the row objects. So I hope the things were clear here. And this is how you write the queries, not queries, data frame APIs, how we use it. As you can see, almost everything looks like a relational style programming. Now we will also see the other nested queries that we saw in the SQL. The same thing we can do it with the data frame APIs also. Again, data frame APIs we can open. As usual, we are reading our data frames using the data source. We are reading the data using the data source API. We got our sales data frame. We got our customer data frame. So we have just the join method. Join customer data frame, sales data frame. I mean to say sales data frame. Join method takes on what data frame we have to join it and what condition we have to give. What condition we have to give. As I said, if we don't specify any condition, if we don't specify any condition, by default it does a Cartesian product. If we specify the condition, by default it does inner join. So if you want to do outer join, so that will be the last parameter. I mean to say join is a method which is taking these parameters. Join is a method which takes these parameters, the another data frame, the condition, and what type of join. If by default it will be inner join. Now if I want to do outer join, we just say okay. So this is how we outer join, left outer join, right outer join. That will be the third parameter, third parameter to your join method. You can hover on that and click for the definition. So as we can see here, the definition, the data frame, join expression, and finally the join type. So by default, the join type is inner join, but we can also have outer, left outer, right outer. These kinds of joins will be there. So I hope the way the joins work also is clear. I had one document. I don't know where I have kept it. Yeah, yeah, I have a small document here. Yeah, as you can see here, we can just say data frame 1 dot join data frame 2. It will do a Cartesian join by default if you don't specify any condition. If you don't specify any condition, just to showcase these things, we can run these things on the Spark shell also. Just for how to use the Spark shell. Till now we have been seeing only in the IntelliJ, and most of the times in the companies we always use the IntelliJ. But Spark shell can also be used for testing purpose. Spark shell is usually used for testing purpose, not for full-fledged development of your project. Just for simple testing you want to do, you can use the Spark shell. What I am trying to say here is we can think of Spark shell as a BI tool, but a simple console-based BI tool. A console-based BI tool, not much thing we can do. uh, Using the logs and prints, we only that's the way you can debug. Here is a question. The question is how to debug Spark programs. I mean, you have to put the prints and then check the logs. You can use log4j, those things, and check the errors. So you can use the Spark shell in this fashion. Just a second. Let me check whether we have. So this why I'm giving this, when we by default you can start the Spark shell by just giving Spark shell. I'm also giving the MySQL connector because I have changed the configuration file in the Spark shell. I have added, I have copied the Hive site.xml to the Spark conf so that Spark should be able to connect to the Hive. Spark should be able to connect to the Hive. And my Hive metastore is MySQL database. Now, when you start the Spark shell, since the Hive site.xml exists in the Spark configuration folder, it will try to connect to the Hive metastore. And to connect to the Hive metastore, we need this MySQL connector, which is the Hive metastore is a MySQL database. Otherwise, if you had not copied, so I will just show what I have copied. If I go to opt Spark, using this. Yeah, if you see, I have just copied hivesite.xml to my Spark conf. By default, it will not be there. I have just copied that. The reason I have copied is so that I can integrate, write from Spark to the Hive table, read from Hive table, all those stuffs I want to do. Otherwise, this will not be there. Now, whenever this exists, whenever whenever the Hive site.xml I have copied to the Spark conf folder, now Spark will try to connect to the Hive metastore, and my Hive metastore is MySQL database. As a result, I am just saying Spark shell with MySQL connector. Otherwise, we don't need this. Otherwise, this is not required if you don't copy this Hive site.xml. If you give without MySQL connector, it will not start the Spark context, or it will not work properly. Just think of Spark Shell is just a BI tool, a console based BI tool, nothing more than that. You don't do a full fledged development with the Spark Shell. It is just for understanding purpose you can think of. And MySQL, this jar file exists in the downloads folder. That's the reason I'm starting the Spark Shell in the downloads folder. So you can just create a data frame just from the list itself. Just I'm trying to showcase different joins that we are doing. I have a small case class with ID and name. Class A, ID and name. This is class A. So I will define class B. I will share this document. I think I did not make it shareable. I will share this. We are defining two classes. Class A, which has members ID and name. Class B, which has members ID and name. Now, if you want to create a data frame, we can also create a data frame from a collection. We saw a data frame being created from a RDD. We saw a data frame being created from a RDD. You can also create a data frame from a simple collection. Simple collection like list, sequence, array, From this also you can create a data frame. You have a collection, convert that collection to a data frame. Just use a 2df method, 2df method to convert a collection to a data frame. And that's what we are doing here. Sequence is nothing but a collection. Sequence is a collection. We are having a collection of this case class. Collection of this. This is an object of that. This is the one more object. We have two collections. A sequence is a collection. We just say to df here. These are all for testing purpose. Whatever we do, these usually will be for testing purpose. So this is data frame 1. You have a collection of A objects, and we get a data frame. Okay, connection refused. Oh, my mistake. For this to work, we should have our Hadoop up and running. I did not start the Hadoop at all. YARN may not be required. We don't require YARN because it tries to connect to the file system. The Spark shell here tries to connect to the file system. So our file system should be up and running. I'm rerunning the Spark shell here now. So by default, it creates a Spark context. By default, it creates a Spark session. As I said, from 2.x, Spark session will be used, and all the Spark context, everything will be wrapped inside the Spark session. So you can use the Spark session, which is renamed as Spark in your Spark shell. So let's create this two data frames. I'm just trying to showcase how these two data frames are created and show. So data frame from a collection, a simple collection. So as you can see here, data frame 1, the schema it took from the case class, because each element of our collection is a case class object. So it took the schema from that ID, which is begin name as string. Similarly, second data frame, we are creating a B object. So B object, we also have defined the same thing. So you can showcase what is data frame 1 dot show you. It will show a data frame. From the sequence we got a data frame. Data frame 2 dot show, if you see, from the data frame, from the collection, simple collection, we got our data frame. So if I say data frame 1 dot join and specify data frame 2, I am not giving any condition on which condition it has to join. I am not giving that. So it has joined the data. We will say val joined df, because nothing gets evaluated. It's a lazy transformation. Nothing gets evaluated unless we give a action. Join the data frame dot, whenever we say only show, now the actual things will work. What happened? Join condition is missing or trigger. Use the, oh, okay, with 2.0 they have changed it. I think from the 2.0 they have changed it. I think we have to specify some kind of a detected Cartesian product for inner join between logical plans. Yeah, here just before giving the actual code, here is a question. The question is, what was the use of the connector? What was the use of the connector? The use of the connector is to connect to the Hive metastore. The Spark shell will try to connect to the Hive metastore because I have copied Hive site.xml to Spark folder. To the Spark conf folder, I have copied Hive site.xml. So as you start your Spark shell, it will look for that configuration file. So there also exists the Hive site.configuration file. So in the Hive site.configuration file, I have configured my Hive metastore as MySQL database. It will try to connect to that MySQL database, but we need the driver to connect to the MySQL database. Hence, I have given the connector. So I hope, Samir, that was clear. I think from 2.0 they have removed this. Usually you give a condition there. You give a condition in this fashion. You join in this fashion. Join data frame equal to this. Join df dot show should give you the result. Now I also wanted to showcase a slight difference here. We use triple equal to sign for the join condition, where the ID of data frame 1 is equivalent to the ID of data frame 2, ID of data frame 2, and it has joined. So similarly, so there is one more thing. There is one more thing called this. You can also use this equality test that is safe for null values also. So null values will also be taken care of with this. As of now, we don't have null values, but null values will also be taken care by this. Now here we are giving only one column. Here we are giving only one column. You can give multiple columns on which you want to do the join. I want to do the join on multiple columns. So either you use such kind of a command. The condition is this and one more condition similar to this. So you can use such kind of a condition. Multiple columns you want to use as a join, you can, or you can use a sequence. So I want to join on ID, I want to join on name, something like this. But here we don't have the flexibility like lesser than or greater than. So those kind of stuff. Here it will be used for only equal sign. It will check whether ID and name are same, only then those records will be joined. So you can also give a collection of joined columns. This way also you can give it. Or this is also more flexible way of giving. This is more compact. This is more compact. This is more flexible. I mean just to showcase the difference between this and this. Just to showcase the difference. So I have put some null values in the data and I'm converting it into a data frame. So let's create these two data frames and check how it looks like. So we can see how the numbers data frame looks like. So this is our numbers data frame. It has number 1, 2, 3, 4, 5, 6, null and blank. Nothing is there. Nothing is there. Similarly, I have letters data frame dot show numbers and letters 1, 2, 3, 4, 5, 6 null and nothing. And we have letters for that A B C X Y Z Z Z Z H H something. Now let's try to join it so that we can see the difference between this symbol and triple equal to symbol. So first we'll see with the normal symbol. So what we are doing is numbers data frame join the letters data frame on the condition numbers of the numbers data frame must be equal to numbers of the letters data frame. This is our join condition. And again if you want to drop any column, we just use a drop. Drop is a method to drop a column from a data frame. And we are just dropping the numbers column because we'll be having two numbers. We'll be having two numbers column. We will delete one numbers column. So if you see here, 112 we got ABC, 456 DEF, null string, no string, empty string. It was mapped here, but null was not mapped. Null mapping was not done here. So if I use instead of this, if I use the other condition, so null will also be taken care. Null is also taken care. Here is a question. The question is union also does same like join. I didn't understand the question, Naveen. What was the question here? But the question is this: Union also does same like join. Can you elaborate on the question, Naveen?
Yeah, Pramod. So, union also combines two data frames, right?
1 second. Yeah, your voice is a bit low. Can you?
Yeah. My question is, union also combines the two data sets, right? I mean, two
No,
data frames, right?
union is vertical combining as Saurav has given. So everything should map.
Oh,
You mean to what I'm trying to say here is union is nothing but you have sales 1.csv, you have sales 2.csv, you have transaction ID, customer ID, item ID, and 40 rupees, transaction ID, customer ID, item ID, 50 rupees. Here we have transaction ID 3444, 60 rupees, 1144, 70 rupees. So let's assume that this is one RDD, or just assume this is one data frame. This is one more data frame. So when we say union, you will have this data frame, then you will have this data. This is the union. Join is different. Join is on some condition we join. This is union. So as you can see, that's the difference between triple equal to sign and equal to sign with greater than and less than symbol. This is also a join condition. It is also take care null into consideration. I mean, I haven't used this just to showcase how it works. Now you can give your inner join. As we know, we can give all other types of join as well. Just how we do the normal joins here. So I hope these things were clear. The simple examples, all those things were clear. One more thing is remaining. No, almost all the things are clear. Join we have done. Customer data frame, sales data frame. So I don't have an example. I had one example where there were multiple columns, but it is almost same. You have to just say this, then and condition, then give the other join condition. On one more column you want to join, you can join that way. Now we also saw how to compute the total, all the users whose total amount is greater than 600. There we use the nested query. Here we are following some logic, that's all, because it is a data frame API. So obviously this will give you the total amount per customer. Group by customer ID, aggregate amount as total amount. So you get the total amount per customer. So on that we have a filter function. This is not a higher order function. As I said, we it's we don't use the we lose the functional style programming. This is not a filter higher order function. It is a relational filter function. You just pass a string on what you want to filter. It's just like a where condition. You can also use the where condition here. Instead of filter, you can use where. So it will filter all the records which is greater than 600 rupees. And we get the same result. So if I run this program, let's run this program and check the result. So we are getting error or cannot resolve symbol amount paid again because I have changed it to item value. Column name is item value. That's the error. So as you can see here, we get customer ID, total amount, customer ID and the total amount. All these amounts are greater than 600, greater than or equal to 600. So as we know that this returns a data frame, we can again join this data frame with the customer data frame to get the name of also the customers who are spending a lot. So you can also get the names. We can join this data frame with the customer data frame because it returns any operation on a data frame, any operation on a data frame always returns a new data frame. This data frame also we can join it with some other data frame. So I hope these simple operations and the join operations were clear on the data frames. You first read the data, prepare your data frame, then you start giving the queries on your data frame. Either you give the queries through the Spark SQL, or you give the queries using the data frame APIs. Either this way or this way. But both if you take, it looks like a relational style program. We lose functional style programming. So why I am stressing a lot on that we lose a relational style, we lose functional style programming. The reason I am stressing a lot on these stuffs is let's give a difference here. I just want to give a difference. We have our RDD, we have our data frame. We know that data frames are faster. Data frames are faster than RDD. So our goal has to be always to create a data frame, and it is recommended to go with the data frame APIs itself. Now, even though data frame is faster than RDD, data frames lacks certain things. So RDD is about functional style programming. Data frame is relational style programming. RDD is type safe. Data frame is not type safe. RDD has domain name. I will explain these things. We lose data frame does not have domain name. So one more difference is there that we will see later. Now, what do I mean by this? So mainly everything is concentrated around this type safety. All the points is Almost all the points is concentrated around this type safety. Now, what do I mean by this type safe? When I say type safe, it means that you get the errors at the compilation time itself. In data frame, you will get the error at the run time. So it is safe with respect. And any change that happens, if you change the type, you will get the error. That's what we wanted to say here. Just to showcase an example. Just to showcase an example. So we have our case class. So we know that from this we read the RDD and we convert that RDD to a data frame. Now when I say RDD, it is an RDD of sales. Now that's what we call as a domain name. Sales is a domain name. Just a jargon it is being used. I'm using a jargon. Domain name it represents the name of individual objects. So 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 for example, sales. Here data frame does not have a domain name. How internally the objects are represented? Row objects. So you lose the domain name. You lose domain. RDD is type safe. Just to showcase what we mean by RDD is type safe. Now since each record is a class object. If I say what instead of item ID, if I say item ID 1, so I will get the error then and there itself. It is a compile time error. During the compilation itself, you get error. You don't have to run this program and then find out that there is a error. But if you see in the data frame, every time we used to get amount paid column does not exist. Amount paid column does not exist. So earlier it was, but it does not give an error at the compile time. It gives the error at the run time. So that's what we say is not type safe. So if you get the errors, most of the errors if you catch at the compile time, and most of the errors if you catch at the compile time means your data structure is type safe, but data frame is not type safe. I hope you got the difference here. I mean, it is good to get the errors at the compile time because you can solve the problem very easily. Getting the errors at the runtime is it's very hard to debug sometimes. So all these things, even though data frames is good, we lose all these stuffs. Functional style program we completely lose. The domain name we lose it because internally it will be converted into row objects. Again, since the domain name does not exist, the type safety will also be gone. And this difference, why we are seeing this difference? So this is what they covered in the Dataset API. So this is the latest APIs that is available in the Spark. Earlier, the very first API is RDD API. After RDD API, we get Dataframe API. Now the latest API that we are having is the Dataset API. And and it is recommended always to use a Dataset API. Dataset API is the recommended API. I mean, these two are the recommended API. So RDD API will remain internal API. This is a recommended API for developers. Spark app developers. So I hope you got the difference here. Now Dataset API is nothing but whatever were the drawbacks of the data frames or the good things about the RDD is brought back in the data sets. So whatever we had lost functional style programming, we had lost type safety, we had lost the domain name. So all those things has come back to the Dataset API. So we saw that most of our programming here in our data frame was relational style programming. If we had to use a functional style programming, we had to operate on row objects. Now all those things have been removed and now we have the data. I mean, a data set is all about combined these things together. Dataset API has both the things together. You have RDD also, you have data frames also. This is your data set. Now you can choose to write relational style programming, or you can use functional style programming. That's the goal of Dataset API. And also to catch the error, most of the errors at the compile time itself, not to leave it at the runtime. So that's the idea of Dataset API. So I hope you got the idea why Dataset API came into picture here. Why Dataset API came into picture. So if I go back to that accumulator example, I will just go back to that accumulator examples, so that we had seen in our Spark core. There I also showed how it works in the Spark 2.0. We also showed in how it works on Spark accumulator. We saw the simple accumulator and the custom accumulator. So just to showcase how this dataset API looks like, just to showcase how a dataset API looks like. So we know that we use the user data. If you remember, we used user data, not this user data.cf. We had user ID, we had name, location, upvotes, reputation. So if you remember, we used the accumulator example, custom accumulator example to understand. I mean to see how custom accumulator is written, and the problem statement that we solved is total number of users per city. So for Bangalore, how many users are there? For Pune, how many users? For Hyderabad, Chennai. So that problem we solved, and we use the latest API to read the data. But we did not concentrate more on that. I said that we will discuss it later. So if I open that program now, so as you can see here, we use the Spark session, and I said that Spark session always wraps the Spark context inside that. It is a wrapper API. And on the Spark session, we use the same data source API. There is no difference. We have seen this data source API. So we use here also with respect to data set also, we use data source API doesn't change here. We are only changing the data frames. We are only changing the processing framework APIs, not the reading and writing framework. The data source still remains same as it is. So we use read dot format instead of Spark context. We use Spark session read format, and this we know read dot format dot options dot load. We know that this returns a data frame. This returns a data frame. This is a common thing we have already seen. This returns a data frame. At the last, we have one more thing extra. So if you remember this, so this is what it makes a data set. Instead of data frame, now it is a data set. Now, whatever holds good for RDD, whatever holds good for data frame, the same things hold good for data set also. RDD we know that is a collection. Data frame is also a collection. Data set is also a collection. RDD is immutable, we said. Data frame is also immutable. Data set is also immutable. RDD is lazy, RDD is distributed, RDD can be cached. The same thing holds good for data frame also, and same thing holds good for data set also. Data set is also cached, data set is also lazy, data set is also triggered by actions, immutable. All those stuffs that we described about RDD holds good for both the data frame and data set also. Now let me remove this. As user, we will, as soon as we remove that, we know that user data is a data frame. User data is a data frame. So once you have data frame, we know that uh, nothing we can do as a functional style programming. Nothing we can do with the function because everything will be a row object. So we lose these stuffs. Now what we just do is we associate that data frame, we associate that data frame with the class name as user class. So if you see our user class, we have defined a case class user with id long, name string, location, upvotes, a reputation. So now if I hover on this, now you can say that this this is now a data set of user. Almost looks like a RDD because we are getting back all our, instead of RDD of user, we have a data set of user. So we get back all the good things about the RDD back in our data set. And this data set still goes through the tungsten and the catalyst. And it will be than faster than the RDD. The file name is custom accumulator. So if you, I think I explained this custom accumulator in the Spark core session, which is there in Spark 2 examples. The project is different. The project is totally different. Spark 2 examples. In that we have custom accumulator. In there we have custom accumulator. So the main method, main function, we are describing it to have a. So as you can see, RDD also had the same code. We could use for each higher order functions, all those things. Now also we can use the for each higher order functions. I mean, we are getting back our functional style programming. We just associate to a data set, to a data frame, a case class, so that becomes a data set. To your data frame, just associate a case class, it becomes a data frame. Sorry, for your data frame, associate a case class, it becomes a data set. Now each record is a user record. Obviously, only the members of this user class we can access. I cannot say location one here. Obviously, immediately I will get a error. Immediately I will get an error. I can also use our normal select queries also. On user data, I want to just select some columns. I want to select id, comma, location. I have id, I have location. I can use the select query also. We can also use the data frame APIs also on this. Both we have now. So if user data, if I want the functional style programming, I say map, take each record, record.id, record.location. So you get both the functional style programming and the relational style programming with your dataset API. So that's the main idea of the dataset API. Bring back the good things of the RDD. Functional style programming is one, and type safety is the other one. Type safety is the other. So I hope why dataset is clear. Why Dataset API is clear here. We get back all these good things in our Dataset API. So with this we will wind up the session and we will continue tomorrow. So before going here, there is I will just give a example. So there are some files here, some CSV files. So this file has around 37 columns. This has around 45. This has around 50 columns, 30 columns, 70 columns, 80 columns. But all belongs to the same data. So I just want you people to try this. I want you people to try this. I mean, it's not simple, but it will be helpful. As you can see, so this is the column name. Distinct ID is one column name. Android app version is one column name. Android app version code. Some column names are there, and we have certain values. Now, as you can see here, certain columns are prefixed with some symbol. Dollar symbol is there. There could be other symbol also. Campaign, as you can see, other symbol is also there. City symbol, campaign symbol is there. Now you have to remove that from your header. You have to remove these special characters. You have to remove these special characters. Some has special characters, some does not have special characters. Now the problem arises when you remove special characters. Let's say I remove special character now. Now I get two columns with the same name. So you have to make one of the column as _1, some _2 or anything. So you have to first remove special characters. After removing special characters, you will get duplicate columns. So those duplicate columns has to be renamed. Those duplicate columns has to be renamed. I will share this file. I will share all this file. Just try that example. Try this example. Now here we have some 30 columns. 30 columns. Here we have much more columns. Somewhere around 81 columns. I don't remember. Somewhere around 81 columns. So here again we have campaign duplicate. So also we have email will also get duplicate. Email is prefixed with the symbol here. Here also we will. If you remove the special character, you will have two email columns. So you have to name one of them as _. Now finally, so it means that here we have somewhere around 81 columns. Here we have somewhere around 30 columns. So you have to add the missing columns to this file. You have to add the missing columns to that file, and finally you should have one data frame. So finally you should have a one data frame, but We don't know, some columns are missing here, it may exist here. Some columns are missing here, it may exist here. Some columns are missing here, it may exist here. Some column names are prefixed with special characters, we have to remove that. After removing the special characters, you will get duplicate columns. So you have to rename that duplicate columns. So just try this example. I mean, it is not a simple example, but a very bit of a complex example. But it will give you the understanding of how programmatic schema. Most of the time, most of the thing here is you will need to do programmatic schema. We have learned how the programmatic schema works. We need to use that knowledge and try to solve this. So I will share this data and you can try the example. So let's wind up the session and let's continue tomorrow. Thanks. Thanks everybody. Have a nice day and good night others.